But we're absolutely delighted to have Donovan here at Redgate headquarters in Cambridge, England. We actually have a nice sunny day, so it's great. Donovan is the Principal DevOps Manager on Microsoft's Cloud Developer Advocacy team and growing this team to continue promoting Azure and DevOps solutions. Before joining Microsoft, Donovan spent 7 years as a process consultant and Certified Scrum Master. And I'm just going to hand it over to Donovan now so we can get started hearing more about the Microsoft DevOps transformation. Thanks, Donovan.
Oh, my pleasure. Thank you so much for having me. A little bit more detail about who I am. I've been at Microsoft now for about 4 years, and as Stephanie was saying, I was a process consultant before I joined at a partner. So I've been in the DevOps world for quite some time, and it's really nice to be able to work at Microsoft where I can take that passion for process and DevOps and actually apply it to help our customers be very successful. If you are struggling or you have questions about DevOps or you have questions after this session, the best way to get a hold of me is at Donovan Brown on Twitter. I am notorious for being on there to make sure that I can help our customers be successful. As you see on this slide, I'm very competitive, and you can actually use my competitive nature to your advantage. You can actually tweet at me things that you think some competitor does better than I do, and I will actually get the team involved to figure out how we can correct that for you. So use that to your advantage. What we're going to be talking about today is how Microsoft has taken this DevOps transformation that so many of our customers are on so that you can learn how we've done it and hopefully learn from our mistakes and not make the same mistakes that we've made. This is just where we are today. We don't by any means think that we're perfect, but I believe that we've done a lot of interesting things to allow us to move as quickly as we do and to continue to innovate ways that we can even move faster. So the whole goal of this is just to share with you what we've learned, how we run our teams, to give you some ideas of ways that you might be able to run your teams as well. When I took my previous role, before I became part of the Azure team that does advocacy, I was this program manager for DevOps for Visual Studio Team Services and Team Foundation Server. One of the first things that I was asked to do was to define DevOps for Microsoft, which I took extremely seriously. I always joke that it took me 30 days to write the sentence that you're about to see, but I believe in one sentence it succinctly describes the essence of DevOps, and it helps us drive forward when we talk about DevOps at Microsoft on what our goals actually are. And when I say it today, throughout the time that we're together, this is what I mean when I say DevOps. DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. Value is the most important word of that sentence. I did not say deliver software. I said deliver value, and value is what we actually want to be able to deliver to our customers on a continuous basis. To deliver value, you have to monitor your application while it's running in production to make sure that what you've just delivered is actually valuable and delivered value to your customers. Because if you don't monitor it, you're just guessing. You just hope that what you've just delivered was valuable to your customers. They might not even be finding those new pages that you've developed. But if you monitor your application, you'll be able to determine, certainly, we delivered value, and we need to do more of that. People, by far, is the hardest part of this definition to fix. People resist change, especially if they've been successful with the way that they've been doing it today. Why in the world would they change the way that they're doing it tomorrow? The reason why is because your competition is. And if you don't, your competition is going to pass you at a speed that you're never going to be able to catch up with them. The process, I believe that's the easy part. We know how to do this, but we have to make sure that people want to do this. And what we do at Microsoft is we enable you with the products necessary to follow a process to enable your people to do amazing things. So when you have that DevOps conversation, it does boil down to those three pillars: the people, the process, and the products. And what I'm going to talk to you today is more about the people and the process that we have internally at Microsoft. But just don't even worry. We use our own products internally, which is another reason I think our products have matured so fast, is because we do the same things that we promise and we practice with our own tools internally. When we started adopting DevOps at Microsoft, we realized that our team started to have these habits. Now, these aren't DevOps best practices. These are habits that we noticed that our highly functioning team started to develop. These are habits that they bring into their everyday life. For example, managing technical debt, which I'll talk about more later, was really a key enabler for us to be able to move at the speed that we move today, but yet still deliver a high-quality product. Making sure that we focused on production first. So many of our customers will work on a particular product with no idea how they're going to deploy it. And not until they're done with it do they finally look up and say, okay, great, we have this amazing product. Now how do we deploy it? And they go through this enormous exercise to figure out how they're now going to finally put this into production. You could have done that first. You could have literally laid the pipeline, the entire DevOps pipeline from the fingertips of your developers into production before you wrote a single line of code. And that becomes the vehicle that drives that value to your customers, not something that you're dreading having to do later on. Also, the flow of customer value, making sure that we have that pipeline that we can lay down that allows us to automatically deploy our code into production. We give our teams autonomy so that they understand what our goals are from an enterprise perspective, but we give them their freedom to do what they need to do to be successful. Now, this is really fuzzy, right? This isn't stuff that you can go and point a finger at and say, this is how you do that particular thing when you're looking at it from a habits perspective. So what we did is we then aligned all of these habits to DevOps best practices. You're going to hear me say things like continuous integration and continuous delivery, technical debt, and automated testing. And these are terms that you should be familiar with, and they all map to the habits that we saw our teams actually exhibiting as we started to move down this transformation. And these habits help build the culture that we want to cultivate at Microsoft so that we can continue to do this for our customers going forward. So let's talk specifically about how Microsoft did this. Microsoft became Agile as we transformed from a boxed product into a service version product. What I mean by that is in 2005, we released a software called Team Foundation Server, or TFS 2005. Well, that's a little bit of a misnomer. The version was 2005, but the product actually didn't ship until February of 2006. Why? Well, we were a waterfall shop back then, and we did what most waterfall shops did. We took all of our requirements, we coded for 18 months. Based on our assumptions, we thought we'd finish in time. Well, after 18 months of coding, it took us another 18 months of hardening and testing before we could actually ship, which pushed us all the way out into 2006. We went away for another 2 to 3 years, and we brought out 2008 version of Team Foundation Server. Again, a very waterfall approach where we assumed that we knew what you needed 2 years in the future from where we were at that particular time. Unfortunately for us, our competitors were doing it differently. We had competitors focusing just on version control, or just on work item tracking, or just on continuous integration, and they were innovating at a much faster rate than we were. So when we would disappear for 2 years and come back in 2010 and 2012, we were still behind. We had to figure out a way that we could move faster so that we could keep up with the trends of the industry and innovate beyond those that we were competing with. Now, it looks like we did a little bit better between 2012 and 2013, and that we stumbled again between 2013 and 2015. But if you understand the history of Team Foundation Server, we actually started to hit our stride. In 2013, we produced an update every 3 months, and we continue on that cadence today for our on-prem product, Team Foundation Server. Throughout this time, we also shifted from a box product, Team Foundation Server, to what we now call Visual Studio Team Services, which is an online offering of the exact same functionality. But we ship that every 3 weeks. So we went from a 3-year cadence down to a 3-week cadence, delivering more value at a higher quality than we've ever done before. And what the rest of we're going to talk about with our time together is some of the process changes, tooling changes, and architectural changes that were required for us to go from a 3-year cadence down to a 3-week cadence at Microsoft. Microsoft is a Scrum shop. We have Scrum teams, 39 of them actually, that work together to bring you team services every 3 weeks. Our Scrum teams are made up of one program manager, which plays the role of a product owner. And then we have our engineers, which make up the rest of your Scrum team. Notice that there is nothing in here about QA. I'll talk more about what happened, but our QA team got merged into our dev team, and now we call them engineers. And there's a very key reason on why we did that. So if you look at how we build our teams, we basically take one program manager, we group them together with usually 8 to 9 engineers, and now we have what we call a feature team, which is basically a self-functioning Scrum team. Our teams are co-located. What we mean by that are all of the individuals on a particular feature team sit together. This is a picture of a room in Building 18 at our Redmond campus in Washington. And you can go into one of these team rooms, and everyone in that room is working on the exact same team. It's a really powerful concept to be able to be this close to the individuals that you work with on a daily basis. When it's time for our daily stand-up, we just stand up. Everyone is in earshot of each other. You answer the 3 questions, and you simply sit back down again and get to work. What's really nice about this is the level of collaboration that we have. There is no need to have to bring up technology to connect with someone. You can just swivel your seat around and have a conversation with the individual who might be working on an API that you're trying to use. What's really nice about these rooms is that we actually have 2 focus rooms for every team room, which allows groups of individuals to go into a room, close a door, have a whiteboard session or a more detailed conversation without distracting everyone else in their team room. Each one of these team rooms has their own culture because our teams are autonomous and they're allowed to run their teams the way that they see fit. There are some things from an enterprise level that we do dictate, like the sprint length, which we'll talk about later, but what you do in that room and how that room is run is completely up to the team. Some of these rooms are silent like a library, where others will actually have a war breakout with Nerf guns. So you have to go into those rooms armed because that's how they blow off stress. But every room is interesting to see how individual that they are. The teams stay together for about 12 to 18 months, at which point we do something called a yellow sticky exercise, where the program managers that head all of the 39 teams get up and give a pitch on why you want to come work on source control or work item tracking for the next 12 to 18 months. The team members then get to choose which teams they want to go work on. And historically, about 80% of the people go back to the team that they were originally on. But it's nice to have that freedom to be able to go to other teams and maybe start learning how work item tracking works versus build, or how release management works versus work item tracking. So our teams have the ability to float around, but we keep them together about 12 to 18 months together. We also have cross-discipline teams, and that became paramount when we moved our QA team into our engineering team. As Scrum teams, we sprint at a 3-week cadence. We tried 2 weeks and it felt too fast. We tried 4 weeks and it felt too long. And 3 weeks, like Goldilocks, felt just right. It just fit. And it was the cadence that we've been running for, so many years now I can't even remember. But if you'll notice, those bars look a little bit longer than 3 weeks. The reason why is because our deployment of team services goes through something called rings. Each ring has a collection of scale units in which we're deploying the instances of Visual Studio Team Services every 3 weeks. And it takes about a week, assuming everything goes perfectly, for the code to get from the first ring all the way out to everyone in the world seeing the new version of Visual Studio Team Services. If you'll notice, though, our sprints are only 3 weeks long, not 4 weeks, because our deployment is completely automated. No human beings have to stop what they're doing to actually let the code deploy. It deploys to a ring. It sits there and bakes for 24 hours. If there are no LSIs or live site incidences or issues that we need to go and address, that code will then be deployed to a bigger ring. And as it's being deployed, we're using lots of telemetry to make sure that we can monitor the health of that deployment. And assuming everything is green, a week later, it has been deployed to every instance of Visual Studio Team Services. It's really important that that be automated. Otherwise, our capacity for our next sprint would be impeded by people having to do maintenance on the application that's being deployed or having to help manually deploy that particular piece of code. So our sprints are every 3 weeks. And let's go ahead and dive a little bit deeper into how our sprints get broken down. And this is one area where I'm talking about our teams have autonomy, but there are certain things that we dictate. All 39 teams are sprinting together in a 3-week cadence. It makes sure that the coordination is very, very seamless. When you have lots of different teams all running at different cadences that depend on each other, that can cause problems when you're trying to do planning. But it becomes very easy to do, I shouldn't say very easy, but much more manageable when everyone is on the exact same sprint cadence. I think we're in sprint 119 or 120 at the moment, and every team across the globe, because we have teams in Raleigh, North Carolina, and Seattle, we have them in the UK, and we also have them in India. They're all on the exact same sprint. They all start and end at the exact same day. So if we were to kind of dive in a little deeper on a sprint, the sprint starts with sprint planning, which is about 2 days of taking our code, our work items, and breaking them down and making sure that we can achieve our goal at the end of the sprint. At the end of the sprint, we're done, which is 3 weeks later, and then the deployment starts, which overlaps the first week of the next sprint. Again, we don't have to stop what we're doing. We just keep on sprinting 3 weeks after 3 weeks after 3 weeks. We don't break the 3-week cadence, but there is one breakage in the deployment. Every year, there's a deployment that happens over Christmas. With so many people taking vacation, we don't risk deploying over Christmas. So the very first deployment after the new year is actually a 2-sprint worth of work actually being deployed the first deployment of January. But the sprints never stop. They're always 3 weeks. We don't have to adjust them for vacations or holidays. It's one after the other with a deployment, with only the exception being around Christmas. So how does a company or even a team that has 39 feature teams actually coordinate across 39 feature teams with different teams being in different actual geographic locations. The way that we do it is we do our sprint plan through an email. So all 39 teams send out a sprint email that contains their goals for the next sprint. At the end of the sprint, we get another one showing us exactly what they accomplished, and it actually has a video inside of it that shows the new functionality being demoed by the program manager. An interesting side note about that video, it actually was a forcing factor for the development teams. To make sure that it was in the video, they had to get it done sooner and make sure that it was well tested so the program manager could produce the video. You can't use any special effects or any special software to make it look like the feature is working. The feature actually has to be done. So it gave the program manager an opportunity to see the feature as they were recording the video and give additional feedback to the team that they might want to go polish it a little bit more, and then he could re-record the video, or she could go re-record the video. It's really interesting because I don't believe that was the intent of the video, was to be a forcing factor for developers to go get work done sooner, but to just make sure that we could communicate our progress across 39 teams. So every 3 weeks, I get a flood of emails letting me know what the team has finished and what the team is planning to do, and I can go back in and keep up with all the other teams across our organization this way. If we go ahead and dive into what these emails look like, here's a couple of samples. If you've been using team services, you recognize this section at the bottom. That's just a query of our work items, and this is the selected group of work items that we're going to use for this particular sprint. At the end of the sprint comes another email of what we accomplished and a video demonstrating exactly what features were added in our particular sprint. By this point in the demonstration, I always get questions about planning. Oh, how do you plan for team services? We do it in several different levels. One of them is the scenario level, where our leadership gets together based on all of their research, the trending in the organization, innovations by our competitors, and we say, where would we like to be 18 months from this day? We hope to get about 60% of this done if we look back 18 months from now. We then work in what we call 6-month seasons. We have a spring moment that usually happens around the Build conference and a fall moment that happens around the Connect conference at the end of the year. We take this and we hope to get about 80% of what we planned for the next 6 months actually done. And then we run our 3-week sprints. Every 3 weeks, we go back in and we recast what we're going to do for the next 3 sprints. After we've sprinted for 6 months, we recast that 18-month vision, because it would be very naive of us to believe that after 6 months, where we thought we needed to be 18 months from 6 months ago is exactly the same place we still need to be. So what we do is reevaluate the industry, our competition, and all the signals that we have to determine where do we need to be the next 6 months from now. And then after we do that, we basically use every 3 sprints to replan what we're going to do moving forward. And we never stop this process. So every 6 months, we recast our 18-month vision. We then plan the next 2 6-month seasons. We break that down into 3-week sprints. And every 3 sprints, we go back and we reevaluate what we're working on. So now what I want to do is talk about quality and what happened to our QA team. Historically, we were like most companies where you would have to do what we call a code freeze. So if you're doing a code freeze, that's a code word for please stop writing more bugs. Because we need our developers to stop writing code, because the more code that they write, the more bugs they produce. And if they stop writing code, we can finally have our QA teams go attack their code and start producing bugs, which is essentially a quantified version of their technical debt. We would then take those bugs and we would then try to pay it down or test and stabilize our code. And then we would rinse and repeat this process until we were at a milestone or ready to release our software. This is just an example of a charting of our technical debt when we were using the code freeze methodology of development. And you'll notice that that third peak is quite higher than the first 2. And this makes it really difficult for you to be able to anticipate when you're actually going to be able to ship. If the code that you're working on is new, more complicated, a new technology that you've never used before, you could potentially have more technical debt incurred in the same period of coding than you did in a previous series of coding. And that's because we were putting all the testing at the end. We let our developers just code and code and code with no concern of testing, and then forcing them to test it at the end through our QA mechanisms, and then all this technical debt would come rushing back in the form of bugs. And we needed to manage that much more accurately than we had in the past. So what we wanted to do is take quality from this big curve that we had no idea what was happening and actually monitor it much more carefully. Buck Hodges, who is our director of engineering, Went back and did some research and realized that our developers are able to clear 1 bug per engineer per week. It's almost like the teams could clear a bug per week. So what we wanted to be able to do is monitor it through what we call a bug bar. A bug bar is the number of bugs that a team can have before someone has to stop and go pay down that technical debt. And the bug cap is 5. And we can't let more than 5 bugs be in that team before someone has to go back in and pay down that technical debt. To be able to know how many bugs you have means you have to start testing sooner. So instead of pushing quality to the end, we started shifting it left and actually baking quality into the code and being able to run tests and determine if we were actually on target or not. And then we track this very, very closely inside of Microsoft. So we have something called a bug bar that we then monitor with this chart. This is pulling data directly from team services and allows us to see on average how many bugs that the teams are actually carrying. We do not use this to punish people. What we do is we use this to learn on how good we're doing at being able to stay below the bug bar. As you'll notice, some of these numbers are higher than they should be. Some of them are very well maintained and very low. What we do is we go and talk to the teams who are having trouble maintaining the bug bar and learn why. Was it more complicated than we thought? Do we need more capacity? Did we overcommit this particular team? How can we learn and what can we do to enable our teams to stay below that bug bar? Another thing that's interesting is that when I talk about DevOps a lot, I talk a lot more about the dev than the ops, and I don't think that's fair. But we actually have a report card for our ops side of the organization as well. This engineering scorecard actually spans both dev and ops because live site incidences, or LSIs as we call them, where team services has stopped functioning the way that we want it to, and our customers are no longer being able to get the value that they want it to, we actually track that. How long did it take us to detect it? How long did it take us to mitigate it? And how often is it actually happening? This is actually a sign of our dev team and our operations team because they need to be working together. We need to make sure that we're able to keep a healthy system and deploy code into that system very readily. And this chart allows us to be able to go back in and actually monitor and grade how well we're doing as an organization. An LSI has a couple other forcing factors on it. Whenever we have one, the developer that wrote the code is the developer who actually gets woken up at night. So people always ask me, if you got rid of your QA team, how in the world did you increase your quality? Because developers are notoriously horrible testers because they test the code the way it was designed to be used, not necessarily the way that the user will accidentally use it in production. And the short answer is you can make them carry a pager. What I mean by that is that they need to pay the consequences for their bad decisions and their bad architecture. If the developer who wrote bad code gets to sleep through the night while some other person is up all night on the service call trying to help a customer out, then the person who wrote the bug didn't feel the consequences or pay the price for that bad decision. But when I'm sound asleep at night and my pager goes off because the code that I wrote is causing issues in the system, I'm having to pay the consequences, and it will actually shape my behavior. It'll shape the way that I code. It'll shape the way that I test. It'll make me more defensive in my programming style. It'll have me adding validations where I might not have had to add them before because I now know what our customers are capable of, and I want to sleep through the night. So it's really important to make the people who are making the decisions responsible and own those decisions. So if you write the code, you run the code with the team in operations. On our Scrum teams, someone on that team is on call at all times for the system that it's running. All 39 teams have an individual designated for that. So it's not the same person every sprint. So that pane rotates around, which is really important. We don't want one individual feeling like they're constantly the person having to pay the consequences. So that floats around our teams such that everyone understands well how important it is to have quality baked inside of your software. So this is a way that we're able to grade both how we're doing from an engineering perspective from the development side and also how we're actually running our service in production. So transforming our organization took quite a few things. The one I want to focus on here on this slide is the dev and QA became an engineer. Historically, we were like most companies. We had a separate QA organization that we would throw code over the wall to. They would then go and test the code, and then all this technical debt would come running back over the wall in the form of bugs. Buck Hodges, again, went and spent some time with our QA team and realized that the QA team was bending over backwards trying to test some of this code because of the way that the code was actually engineered. Buck came up with a brilliant concept that I bet if the individual who was testing the code was also the person who wrote the code, if the code was difficult to test because of the way it was written, they would simply rewrite the code to make it easier to test. So that's exactly what we decided to do at Microsoft. What we did is we basically went to our manual testers and said, we really need you to become more comfortable and empowered to change the code to make it better for us to be able to test. Some people who wanted to stay manual testers left our team and went to other teams inside of Microsoft who needed manual testers, while others went ahead and took this opportunity to get more familiar with code and are now integral parts in our engineering team that makes up our Scrum teams. Having this QA mindset melted inside of our organizations and inside of our teams also helps with quality, because they come from a completely different mindset of quality than a developer does. But also making those developers responsible has also increased our quality. The other question that I get when I mention this is, well, how does someone get manual testing done or exploratory testing done? And I've actually witnessed this in a team room where an engineer called over a teammate. They rolled their chair out of the way. The other teammate rolled her chair in front of the engineer's workstation and just went to town on this person's code. They were putting numbers where letters are supposed to go, letters where numbers are supposed to go. They were trying to break their peers' code. It's really difficult to break your own code. It's really easy to try to break your friend's code. And that's exactly what they do. They use that nature of us to want to go and play with and break other people's stuff to make sure that they're actually delivering quality out the door. So it's not one developer is responsible for one piece of code and it's the only person who ever sees it or tests it. They are writing the unit test for it, but sometimes the functional testing comes from an external person or a team member on that team to help put in that quality. And again, we were really lucky to have a lion's share of our QA people come and be merged into our dev teams to help us get high levels of quality. When we had an external QA team, we obviously had a lot of functional testing. When we got rid of our QA team, we had to move to a more unit testing framework. So we've actually changed the way that we write unit tests. We make sure that they're extremely reliable and extremely fast, because as you start to increase your library of tests, which is obviously a good thing from a quality perspective, it can also increase the amount of time it takes you to build your code before you'll be able to deploy it. And you don't want that to be the bottleneck for the way that you deploy your code. You want to deploy code as quickly as you possibly can. So we had to make sure that our unit tests were not only fast, but very reliable. What we mean by reliable is if you've ever had a test that actually passes sometimes, you don't change the code, it starts to fail, you still don't change the code, and it starts passing again, that's a flaky test, and it's clearly not reliable. And some people will start to ignore those failures. Okay, yeah, that test always fails sometimes, so why even have it? What we had to do was go and make sure that our test could be counted on to be reliable and also be very, very fast. A couple other concepts that we had to change was the fact that we went from a multi-year cadence to what we call a cloud cadence. We went from 3 years down to 3 weeks. And 3 weeks is just where we are today. We're constantly trying to find ways that we can innovate and that we can speed up this pipeline for us so that we can move even faster. In 3 weeks, that's when all the teams come together. That's when all the teams are able to realign. But team services can actually be deployed multiple times a day. And sometimes hot fixes are deployed in the middle of a sprint, because again, it's completely automated. We are an entirely Git organization. So in the Visual Studio Team Services team, and let me qualify that. I usually say this at the beginning. When I say we, I am talking about Visual Studio Team Services. I am not talking about Office or Windows or Bing. We're all on this journey, but we're all at different areas and different times of that journey at each company. So I want to make sure I'm very clear that I am talking about Visual Studio Team Services when I say we. We're an Agile shop, we're a Scrum team, and we are trying to work as fast as we possibly can to deliver our software. One other interesting note about our Scrum teams, which was interesting, when we decided to go Agile, we had coaches come in, everyone went through training, and we obviously started trying to learn how to do Scrum. And if you've ever done Scrum before, you know how painful it can be at the beginning. Now, I always tell the anecdote of where when I was introduced to Scrum, I did not realize how poor of a Scrum team member I actually was. I never updated my task in Team Foundation server. If I did, it was always on Friday, so that burn down always looked like stair steps and never burned down smoothly so people could understand what was going on. And the reason that I never knew how bad of a team member I was is because I was always just a team member. I was never the Scrum Master, and I was never having to pay the consequences for those changes or those decisions that I was making. And then long story short, at one point I became the Scrum Master for that exact same team. And then I realized how bad of a team member I had been because others on my team were just as bad as I was. They weren't updating their task. I was having burn downs that looked like stairs. I had no indication of what was going on until Friday at the end of the week. And I realized that, man, had I been a Scrum Master sooner, I would have been a better teammate. So our Scrum Master role and the team services teams actually rotates throughout the organization such that on that team, everyone would have played the role of the Scrum Master and felt the pain of being a bad team member so that when they're not the Scrum Master, they're going to be a better citizen in that Scrum team. So it's an interesting concept. Before I joined Microsoft, I'd never heard of that, but I see the value instantly because it actually happened to me personally as well. We also had to go from a box product to what we call a live site, where there's never an opportunity for us to take Visual Studio Team Services down. It runs 24/7. Just because it's dark in the United States, it's bright over here in England, and they want to get to work, so we can't take it down to update it. We actually had to figure out ways to update our system while it was running and while people were actually using it. And I want to be very clear, that's not just a DevOps pipeline that you're building. That is engineering changes that have to happen to allow you to be able to deploy your software while people are using it, to be able to hide code that's not done yet. It's not just a pipeline that does that. We had to go back in and rethink the way we engineer our software to make sure we could then go ahead and deploy it. One other example of that is the way that we deploy our web services. We have very, very clear contracts, which I'll talk about a little bit later, that make sure that we know exactly what we can expect from one service or another. And our services are so independent now that even if I depend on a future version of you, I can be deployed before that future version exists. And I'm able to then determine if the version that I desire has already been deployed of that dependency, and if not, I can go back and use the last known contract that I know exists there until you are then upgraded to the version that I want you to use, and then on the next session, I'll start using that new functionality. This decouples our services such that they can be deployed in any order that they want, which kind of dovetails into the next slide. That was one of the deployment principles that we had when we were trying to go from a box product over to a live site system. We had to make sure that there was zero downtime. It is never okay to take the service down under any circumstances. Brian Harry is very clear about that. We are never, ever allowed to let the system go down. Our deployment is fully automated. There are no human beings involved in deploying Visual Studio Team Services. And what I love to say is Visual Studio Team Services is tracked, built, versioned, and deployed using Visual Studio Team Services. We do all of this using the exact same tools we produce and sell to our customers. We had to have a joint ownership between engineering and ops. This is DevOps at its core. We had to make sure that our operations team knew the needs of our dev teams, and our dev teams knew how to be good citizens to our ops team so that we can have our ops teams maintain the infrastructure that drives and hosts Visual Studio Team Services. We use DevOps best practices like configuration as code and infrastructure as code to allow those environments to be automatically scaled up and scaled out by simply running another deployment without human beings having to go into portals or into tools to actually stand up or scale out our infrastructure. As I mentioned before, we had to decouple our services and have very clear contracts which you can never break between our services. By decoupling them, it allows us to then deploy our code in any order that we want. No service dependencies actually dictate when one service has to be deployed or another. The way that we're able to do a lot of this is through a concept called feature flags. Feature flags allow us the flexibility to have a long-running feature without having that merge bomb at the end. Historically, and I'm sure many of you listening to us right now, have a long-living branch of some concept or feature that you want to add to your product that simply isn't ready yet. And then eventually, several sprints from now, you're going to try to merge that back into your master branch, and you potentially are going to have a merge bomb. A merge bomb is where you have so many differences or the code has deviated so drastically that any attempt to merge it is going to be catastrophic and actually have a lot of time lost. Which is why one of the reasons we went to Git. Git allows us to have short-lived feature branches which we're constantly merging back into master. But the question goes, if I'm not done with a feature, how can I then safely merge that code into the master branch because that code's not done? And feature flags are the answer to that. Before we're able to implement any functionality inside of Team Services, it first has to register a feature flag. That feature flag is then put in place, and then we code behind that flag. What that means is that code lies dormant until that flag is turned on, which means I can safely merge into the master branch of code where all 39 teams are merging into and ship at a moment's notice because the code is behind a feature flag that protects us from them. Another thing that feature flags allows us to do is when we expose a feature, we can actually gradually expose that feature. I might give it to a subset of people. I might give it to our MVPs, maybe a certain region. I can do A/B testing and determine if the new feature works better than the old feature. And if in the event that something bad happens, I'm able to simply turn the feature back off again. Visual Studio Team Services does not roll back. We only roll forward. Our pipeline is such that we can actually deploy a fix out and mitigate the problem through feature flags such that we never have to roll back the system. If something that we've just deployed out doesn't work, you simply turn it off. You do your root cause analysis that allows us to then go back in, determine what was wrong, put a long-term fix on our product backlog, ship that new fix, and then turn that feature back on and see if it's actually made an improvement to that particular experience. And should it not, we can actually turn it back off again. Another thing about feature flags, which is really nice, is we actually use it for marketing. I mentioned the connect and the build events. Those are events where we actually show off and announce lots of new functionality. And in doing so, it's really important that we make sure that those features don't leak too early. But we have to develop them before the event. So what we do is we simply put them behind a feature flag. And then Scott Guthrie can get on stage, make an announcement. We simply flip this flag, and when we do, everyone is now able to see that new announcement live on the service. We rolled our own implementation of feature flags. It's basically just PowerShell scripts that we run against a database. And I'll demystify feature flags for you right now, guys. They're just if statements. And what you're doing is you're using some external system to determine if that feature should be on or off. We rolled our own because we predated any offerings, but there are offerings out there now. You can go on our marketplace and actually find people who are providing feature flags for you as a service that you're able to then implement inside of your application so that you can have the same type of mature functionality that we have at Team Services and allow you to deploy your code in a much safer way and allow you to have features that span multiple sprints without having the merge bomb at the end. One other thing that I wanted to talk about the LSI that I think I missed was, again, making the developer responsible for the code that they run really helps with the quality. Their pride is another thing that really helps with quality. Brian Harry, every time we have an LSI, actually writes a blog post that explains the root cause of that particular issue and what long-term fix our team is employing to make sure that that never happens to you again. I can tell you firsthand, those emails are hard to read as a team member. You never want him having to apologize to our customers for something that goes wrong in your service. So it's really interesting to see how the developers are rallying around making sure that our customers have a great experience because we are now feeling our pride be damaged potentially by that blog post or other scenarios that are causing us to feel the actual pain of the decisions that we make on our team. This was a change of our process. This was a change of the attitude of our people, and this has actually changed the way that we engineer some of our software. And the software that we use are the products that we're actually selling to our customers. So for us in the Visual Studio Team Services team, to continuously deliver value to our customers, we have to make sure that we're enabling you to do the exact same thing with the tools that we produce here at Visual Studio Team Services. Oddly enough, this actually has gone a lot faster than it normally does. We still have quite a bit of time left, so have we been getting some questions through?
Yeah, we've been getting some great questions.
Good.
And some of them I want to ask the same thing, so I'm going to prioritize those ones. From Ian, he's wondering, what are your thoughts about how you get individuals to want to join teams that they don't want to work on? Say the team is going to have to work on a really hard or really boring problems like reliability or something that just isn't as exciting. How do you get team members to want to work on those teams?
That's interesting. And what I would encourage is I wouldn't want to force a team member to work on any team that they don't want to be on. There has to be something there that makes them want to come to work and sling code. And I think that's why we do the yellow sticky exercises, because we understand that it might have seemed cool to you at the beginning, but now you've been in source control and Git for 18 months and you really wish you could go somewhere else. So what I would encourage versus trying to convince someone they like something that they don't is find somewhere else that they might be able to work more effectively or something that gets them excited. I've been really fortunate in my career that I've had the opportunity to work on things that get me really excited. But I think we've all been in that one where we wish we weren't there, and I wouldn't wish that on anyone. So instead of trying to convince them that that's a really cool product, I would think if there's somewhere else in their organization they might want to go. And we're really unique at Microsoft because we're not just team services. We're Xbox and HoloLens and phones. And I mean, we have so many different places to go. So I'm almost spoiled in the fact that if I ever get tired of DevOps, I could literally go play with HoloLens or go play with something else. So that's a tough one because I don't know that I have an answer for this is how you trick someone almost, for lack of a better word, into thinking that this is cool. If it doesn't excite them, I think you'd be doing yourself and that person a disjustice trying to convince them that that's the team that they want to be on. And that's why we let our teams go to places that they want to be excited about and be passionate about. I'm sorry, it's not really an answer to how you do that because I don't know that I'd want to convince someone to do something they don't want to.
Okay, I'm still searching for that answer then.
But I mean that's an interesting. I understand that's a problem, but would you want to be in that situation?
Yeah,
no,
but
right.
There are times when work needs to get done.
And I think at most organizations, you're going to have that person who's willing to step up and do that. It's not that you have to convince them that it's fun or that it's interesting. You might just need to convince them how important it is for the success of your company. Mm-hmm. There's very little that Microsoft could ask me to do that I wouldn't be willing to do simply for the love of the company for which I work. And I'm sure that might be true for you as well. If Redgate asks you to do something that you really don't want to do, but you know it's going to benefit the company, and that's clear to you that it's going to benefit the company, then I would do that, and I'm sure you would do that for your company as well. So I think what's really important is that you express how important this is and make them see it, and don't just tell them to go do something that you know they don't want to do.
That's a great point.
Okay.
Okay, that's my answer.
Okay.
Do we have time for another one?
Absolutely, we have plenty of time. Actually, I think we have like 20 minutes, actually. That went, 15 minutes almost. That went by a lot faster than it normally does.
All right, so get your questions in now, and we do have a few more. What are your thoughts on the definition of done?
Ooh, that is a fantastic question. First thing is that everyone on your team better agree. There's so many times that I'll meet a team and I can ask every team member what done means, and it means something else to everyone on that team. And that means that the Scrum Master hasn't taken the time to actually define the DoD. And I think it's imperative, because when I ask you, when are you going to be done, if in your head you're thinking all I have to do is be code complete, and you say an hour, then I give you that weird look on your face, like, really, you're going to be able to? And in my head, I'm thinking, write unit test and do a diagram and do the database schema and all this stuff that my definition of done means to me. So if you and I don't agree on the DoD, you and I can't have a meaningful conversation on when anything's going to get done. So I'm very clear when I use tools like Team Services that have a wiki. Our DoD is in black and white. It says to be done, you have to have. What we did is we had a code coverage minimum bar. So we basically said our current code coverage is at 40%. Our DoD means that our code coverage can never be below 40%. So I'm not a stickler on the value of code coverage. I'm a stickler on the movement of code coverage. In every retrospective, we would reevaluate where are we on code coverage. That becomes our new minimum. I'd also talk about, I remember the last team I ran, our DoD said it had to have one manual test written. It had to have no code coverage, code negative, and there was one other one, and it was in black and white. So when I said, when are you going to be done, they knew they had to write a manual test. They knew they had to write all the unit tests to make sure our code coverage didn't go down. They knew they had to be code complete. There was no, oh, I'm not going to do unit tests because that's not in our DoD. So it's extremely important that everyone on your team know what it is so that you can have a meaningful conversation when you're in your planning meetings. Otherwise, your planning meeting is useless because everyone's DoD is different, so those numbers don't align with anyone. That's a great question. Make sure you document and it's clear in black and white what your DoD is.
And it sounds like Ian was having some problems on his team with this, and they finally got to a definition that done includes deployed to production and used by 1% of users. So
interesting. The 1% of users part, that's an interesting spin, because I'm not sure how, but okay, this is a very, very good point. Just because that DoD seems a little interesting with that last part. The first part I understand. The second part seems a little weird to me, but it doesn't matter what it feels to me. The DoD is for your team, and every DoD could be different. There's not a, Donovan, what should our DoD be? I don't know. I have to go talk to you and your team and figure out what does that DoD actually mean. And that DoD make perfect sense for them. But I see that metric being interesting because 1% of our users might not find it because of a navigation issue. Right. It doesn't mean the feature's not done. It just means you can't find it. Right.
But
so
isn't that something you would then want to go fix?
You would want to go, absolutely. You would definitely want to monitor that. I just don't know if I would put that in my DoD. That's the only difference there. But again, that's a great example of where your DoD is for your team. The key point there is that everyone on the team agrees and understands what it is, not that every other team's DoD is the same. And I would tell people this a lot when I was doing Scrum training and I was a Scrum Master at my previous role, is the Scrum that I ended with every company was different, because every company has different constraints. Every company has different goals, different measures. I remember I had some sprints that were 1 week long. I ran, as an example, once. I was with a customer for a while. I only had 1 month left with them, and they wanted to learn Scrum. I was like, well, I can't do 4 week sprint and assume that you're going to understand what this is doing. So for an experiment, what we're going to do is we're going to do 4 1 week sprints so I can take you through all of the exercises and all the rituals at least 4 times. What ended up happening is I got extended, But we stayed at 1 week sprints, even after the experiment, because the team was porting from Lotus Notes to .NET, and we were actually able to produce value very, very rapidly and get projects done in 3 weeks. So running at a 1 week sprint for that team made perfect sense as we were porting. I worked for other teams where a 4 week sprint was the fastest that we could go because our product owner was a practicing physician, and we couldn't get more of his time but every 4 weeks. So having a retrospective and all that kind of stuff more frequently than that really wasn't buying us any value because our product owner, the most important stakeholder we had, couldn't get to us any sooner than that. So 4 weeks really aligned well with his availability and our team's cadence to be able to deliver value. Just like we run 3 week sprints at VSTS. So again, your Scrum is going to become very personal to the team that's running it. Your sprint length might be different. Your DoD might be different. One of the things that I tell everyone is please don't change your sprint in the middle of the sprint. Don't change the decisions that you've made. Even if you realize 3 days into it that this was a horrible decision, just write it out because it might not be as bad as you think once you get used to that over the course of your sprint. Now, at your retrospective, at the end of the sprint, if you all still agree that that was a stupid idea, that is when you make the decision to change it. And that's what I would allow my teams to do is we're not going to change anything during the sprint, but we're going to use that retrospective as a time for us to reflect over what went well, what did not go well, and what we could do better in all future sprints. And that's when we would make decisions to change sprint lengths if we wanted to. I remember one team made the decision to change their product owner in their retrospective because for 2 sprints in a row we delivered the wrong thing because our product owner clearly wasn't the right person steering the ship. But make sure you use those rituals at the right time to make the changes to your sprint, to your Scrum team.
How do you guys handle like high priority bug fixes that come in then?
Great question. So even that happens inside of Visual Studio Team Services. We have a SWAT team. So there's a subset of the team that's responsible for dealing with those emergency issues. And what you need to make sure that you do is you adjust your capacity accordingly. You don't want a critical issue to come into your backlog and then therefore have to push a feature that you'd committed to. So when I'm working on a greenfield application that hasn't seen the light of day yet, I'm very aggressive with my team's capacity. I call it their focus factor. It's never 100%, but it's pretty high. As soon as we ship the very first version of that product into production, I pull back everyone's capacity just in anticipation of something that might potentially go wrong so that we don't overcommit and underdeliver for that particular sprint. As I start to get more confidence in my team, as we start to get more confidence in our process, as we start to realize that we're delivering high code, quality code, I might start to move that capacity out again. But we always leave buffer for you to do those critical showstopper bugs that might result or escape into production.
Does that SWAT team, does that rotate through
that SWAT,
team members?
yeah, it does. That SWAT team, very much like the people who carry the pagers, are elected for that particular sprint. So then not everyone's always on the SWAT team.
Right, right.
And not every company does SWAT teams, but you always need to make sure you have capacity to go and deal with those showstopper issues that might come in.
We have another one around, can you describe the types of automated unit tests you now use? If there's no QAT, and do you use test-driven development strategies, or talk a little bit more about your testing?
Great. So our teams are completely autonomous, and they have full ownership over the way that they do their development. So some of our teams are doing test-driven development, other of our teams are not doing test-driven development. Again, the quality comes through ownership. The fact that they own the code in which they run and they're responsible for it going down and having to be paged has a huge impact on the quality that they deliver, but we do not dictate that they do test-driven development or they do any specific type of testing. But obviously we're heavily shifted on the unit testing because we have to move so fast. Some of the other type of testing that we do, I remember I was asking Brian Harris, I said, Brian, where do we do some of our capacity testing? He says, well, a lot of our capacity testing or performance testing happens in the second ring of our deployment, where we actually deploy it to the smallest subset of public-facing customers. Because ring 0, which I failed to mention earlier, that's us. What I mean by us is that's the Visual Studio Team Services team. Every 3 weeks, the first people to see the features that we've just deployed are us, which means if they're broken, we're the first people to feel the pain. Again, it's about ownership. It's about we're putting ourselves at risk if we make bad decisions. And I think it's very unique for us that we use the products in which we develop to develop the products in which we ship. Whereas if you're not a customer of your own product, that can be really difficult because you're not your first own user. We are our first level user. So a lot of the manual testing and the day-to-day usage of our product actually comes from it being shipped to the teams who maintain and use that product to produce the product. Performance issues are actually determined when we start to scale out our deployment, and we'll start to have lots of influx of public users actually using it as well through our ring process. We have lots and lots of telemetry that's being collected by team services that can actually alert us to the fact that we do have a performance issue. And if we detect one, what we can do is obviously halt that release. We can then go push a fix for that performance issue and restart that release as well. So a lot of the testing, believe it or not, happens in production. And I remember asking Brian Harry that. I said, so we test in production. He said, unapologetically, right? That is we're never going to get better testing than we're going to get from real users using our product. And the fact that we're the first users to use our product means we're going to be the ones who pay any consequences for bad decisions.
I like that. It's the way you learn and, you know, experience the pain for yourselves, like you're saying.
Yeah, because if I remember being a developer where I would make bad decisions architecturally, I'd go to sleep at night, some person would get a call in the middle of the night, not me, having to fight this fire that I created while I sleep through the night. And then in the morning I wake up and yeah, there's a bug on my desk, so I go and I look at the new bug and I'll fix it at my leisure, but I didn't pay any of the consequences for the bad decision that I made. And when you change that, when you flip that around to where the person who wrote it gets woken up at night, that person is much more diligent and much more careful about the code that they write in the future. I might not put a validation for a phone number because I don't think any moron would not put a phone number in there, right? But they're not morons. They're just people who weren't paying attention, were in a hurry filling out a form, and they put something that they put their first name where their phone number is supposed to be. And I go and I try to parse that as numbers, and then all of a sudden my app starts to break. And it's not because they did anything malicious. It's simply because they were in a hurry. But now as a developer, I start to think of what could they accidentally do? What could they do in a hurry that could break my code? And I think more defensively than I would have normally. Because developers are very optimistic. They assume their code is always going to be used the way it was designed to be used. And that is so rarely the case. And I think being responsible for the code that you're running, it makes you think about, okay, what possibly could go wrong? Where do I need to have more protection? Where do I need to do that? Because I want to sleep through the night. I don't want to be woken up every single night with some stupid issue that I could have avoided had I written a better unit test or tested it a little bit harder than I did last time. But when you're not paying those consequences, then you simply, it's not important to you.
So we have another question. How do you gather new requirements or enhancement requests and then prioritize those?
Oh, great question. So there's several different vehicles to where we get those. One of them is User Voice, which is a public website that you can go to right now, and there's one for Visual Studio Team Services, and you can actually put in a new feature idea, and then you can have your friends vote it up, and we actually monitor User Voice for features. Another thing is that we do is we evaluate our competition. Internally, we do something called bake-offs. And a bake-off is where someone like myself will go off and I will do a demo of Visual Studio Team Services. And then another individual from Microsoft will go and learn all they can about a competing product. And then they will then pitch that product against our own product. And we see where their product is better than ours. We vote and see who won. The first time I did one of these, we got annihilated. Like Microsoft's tooling to the competitor, we just got annihilated. And what was interesting about that was how many emails started flying after that bake-off. We're like, this is not okay. How did we lose this? We're better than this. And it motivated people. It really charged us up. And it was funny because my manager said, this email is the reason that we did this. Because I was furious after that meeting. I was like, how is this possible? How did we lose the lead? How are that product so much better than what we're doing? And by evaluating that, our product backlog obviously filled up with all this great innovation that we could do to go be better than that. And that's why I think our Kanban board is so much better than any other Kanban board I've ever seen, is because I know it's funny because I demo some of those features. Like I remember when that wasn't there, and I know why that's there because that competitor had that, and now we have it, and our product is so much better for it. So one of the ways that we get it is User Voice. The other way we get it is basically doing bake-offs, and we do lots and lots of customer visits. I mean, the product group is constantly going out and meeting with customers who are actually using our product to figure out how we can better use it for them. And you got to remember, we're our own first customer. So a lot of those features come directly from us using a product every day, day in and day out, and like, okay, this has to be better than this, and those will go on the product backlog as well. Our program manager is the person who owns that product backlog and does the prioritization. But we also have, remember that 18-month vision I showed you? Mm-hmm. That 18-month vision is owned by our leadership team, and that also obviously affects the priority of our product backlog as well. Hopefully that answers the question.
We just had an interesting comment that they write software for building architects and they don't understand that space at all. So
gotcha.
How do you help more team members be mindful of actual users when they're not in that space?
It's tough, and that's where I think it's crucial that you have a product owner that is in that space. I remember that I told the story about where we actually in a retrospective decided to remove our product owner and get another product owner. And again, that's another sign of your Scrum team is supposed to be completely self-managing, and they are allowed to do whatever it takes to be successful. And what happened is that we had a person who was not a physician being the product owner of a particular application designed for physicians to be used. So the engineers aren't doctors, and nor is our product owner. So he prioritized the features to the best of his understanding. And we go to our first sprint review, and our sprint review is in front of stakeholders who are physicians. And we show them this product, and they're all looking at us like, why did you just show us this? This is not what we need. So we took our beating, we went back, we reprioritized, we came back again, and 2 sprints in a row, they looked at us and said, we still don't understand why you're showing us this. This is not what we need. So we said, okay, we clearly have the wrong person telling us what to design. So we went above their head and said, we need a doctor to be our product owner who can come in here and tell us what truly is important to a physician, because we clearly have no clue. Once we got our product owner replaced with a physician, it was amazing because he looked at our product backlog and completely rearranged everything. And finally, the next sprint, we delivered something that the stakeholders were like, finally, now you get it. That's what we needed to see. So it's really crucial when you're not an architect writing software for architects that you have someone in there, be it your product owner or your stakeholders or someone that you can rely upon and say, does this make sense? Because I can write the code, but I don't know if this is valuable to you or not. So it's crucial to have someone involved in that organization, involved in that project that does understand what it is you're writing software for.
And hopefully involved on, you know, a easy basis where you could.
Yeah, the product owner. Yeah, the product owner is supposed to be someone who, I mean, there's a minimum level of collaboration that they have to be there. I always say they need to be at your sprint planning meetings. They need to be at your sprint reviews, period. They need to be accessible at all times, but they don't need to be there, right? I couldn't ask a physician to stop billing and come hang out with our team until we were done with the software. But what he did do is make himself available to us via phone calls and emails to be able to answer questions mid-sprint that we needed more clarification on. They did make themselves available to us for the sprint reviews, obviously, and also for planning to make sure that what we were going to do next truly was the most important thing that the physicians needed to see next.
And so we have somebody that's been able to sell Scrum to a few teams in the org. How do they take that to the whole enterprise?
Great. So it sounds like, I'm just filling in some blanks here, if he's gotten a couple teams to do it, but the organization's not doing it, it must be from the bottom up that they're trying to move this forward, right, versus from the top down. You will have the the most success ever when the C-level execs get it, or they've been to a conference and they've heard someone speak and they're all excited about Agile and they come back and say everyone needs to be Agile, because then you have the pressure coming from the top and you have the authority. When you're trying to do a groundswell and you're trying to get it from the bottom up, you have to make those teams who have adopted Scrum or Agile so much more visibly performant than those who are not, that people in the executive start to ask, how is this team doing that? How is this team able to produce value so much quicker than the rest of the teams? That to make it almost a forcing factor of the others better get in line because this team over here is shining so brightly that I want to be able to replicate that particular thing. So I usually take a team and I have to figure out a way to make their victories very, very visible throughout the organization so that people start to question and ask, how in the world are they doing that? And then I can go and help spread the word of Agile throughout the organization and hopefully get other teams excited about, hey, man, how are you guys doing that? Because we're struggling over here. Can you come help us do that as well? So it's almost like you want it to spread, but it only spreads if it's visible. You can't have a team successful in isolation and only they know that they're being successful. You need to find a way to actually make sure it's very visible in everyone's mind that, wow, did you see that new product that those produced? They produced it in such record time. How did they do that? So that other teams get excited about it as well. Don't succeed in isolation. Succeed publicly.
That's actually nice because you fail publicly sometimes.
Exactly. You might as well succeed that way too. Exactly. Exactly.
Well, that brings us to the top of our hour. And Donovan, it's been so great having you here.
My pleasure.
I hope this has been helpful so other teams out there can learn from what you guys have done. You know, a huge organization, hopefully take some of those things. If you have any additional questions for Donovan, please follow up with @Donovan Brown on Twitter. He's very responsive because I know I've tweeted him in the past and he's always seeing them and replying.
Yep.
And I also just in the chat window put a link to database DevOps at redgate.com. We didn't get to talk about database specifics here. Again, that's something Redgate is really working hard on to extend DevOps processes to databases and make sure that's no longer a bottleneck in your process. So if you have any questions about database DevOps, please reach out to us at databasedevops@redgate.com. And you should be getting an email in a day or two with the recording for this webinar. So thanks so much for joining us and have a great evening, afternoon, morning.
Bye.
Bye.